Hello everyone, our topic for today is about geometric series. Now let's recall geometric sequence. So geometric sequence starts with a1 followed by a1 times the common ratio r. The third term is a1 r square and the general term or the nth term is a1. Now if we are going to find the sum or the geometric series, then we have to add all of these terms, and this is going to be denoted by S sub n. So S sub n is equal to a1 plus a1r, so which is the sum of all the terms in the geometric sequence. Now, since this is an equation, we can actually manipulate this in such a way that we can multiply both sides of the equation by a certain quantity, then we can choose anything. So we can actually multiply the whole equation by r. So what happens is this. So r times s sub n. If you multiply r to a1, it becomes a1 to the a1r. a1r times r is a1r square. And if you multiply a1r to the power of n minus 1 using the law of index, we will have a1r to the power of n. Now we have two equations right now. So what we can do next is we subtract. So we are doing this because we're trying to derive the formula for the sum of the geometric sequence. So r s sub n minus sn, or s sub n, is equal to r sub n minus s sub n. Now let's try to subtract all of these terms. So notice that a1r minus a1r is just equal to 0. Now it follows for the other terms, and we can say that the terms left will be a1r to the power of n minus a1. So let's write it here. r s sub n minus s sub n is equal to a1r to the power of n minus a1. Then let's use algebra here to factor out s sub n and to factor out a1 at this side. So we will now have s sub n times r minus 1 is equal to a1 times r sub n minus 1. So since what we want is s sub n, we can divide both sides by r minus 1. Now this will give us the formula s sub n is equal to a1, or the first term, times the common ratio to the power of n minus 1 divided by common ratio minus 1. Now, we may also choose to subtract s sub n to r s sub n. So if that happens, the consequence will lead us to the equivalent formula for the sum of the geometric series. So that will actually lead us to a sub 1 times 1 minus r sub n, r to the power of n, all over 1 minus r. Now you see there's a denominator to make them define, then r should not be equal to 1. Now for convenience, you can actually use the first formula if your modulus of r is greater than 1, meaning your common ratio must be less than negative 1 or greater than positive 1. The second formula, it would be more convenient to use the second formula if your common ratio is between negative 1 to 1, or the modulus of r is less than 1. Okay, so these are the formulas in finding the sum of geometric finite sequence. All right, now let's go to example number 1. Find the exact value of the sum of the first 10 terms of the geometric sequence 64, negative 32, 16, and negative 8. So we are looking for S sub 10, the sum of the first 10 terms. So what do we need? We need the common ratio, right? So common ratio is negative 32 over 64, which is equal to negative half. And since negative half is our common ratio, let's use the formula, the one with the 1 minus r. And it will give us, by simplifying this, it will give us 42.625. Or in three significant figures, no, this is the exact answer, 42.625. So there's no need for you to round it off. Now, second example is evaluate negative 3 minus 6 minus 12 minus 24 minus up to negative 768, or up to minus 768. So, of course, it didn't say whether this is geometric or arithmetic, so we can actually identify it ourselves. But we will find out that the common ratio is actually equal to 2. So since r is equal to 2, then we can use the one with the r minus 1 formula. But we don't know yet the position of negative 768 in the sequence. So we need to find the value of n first. Okay, so for us to find it, we can use the general term formula where a sub n is negative 768 and then a1 is negative 3, common ratio is 2. So solving this equation will give us 256 equals 2 to the power of n minus 1. Using the law of index backwardly, 2 to the power of n minus 1 is equivalent to 2 to the power of n divided by 2. Cross multiply that will give us 512 is equal to 2 to the power of n. Then you can use logarithm. Okay, so get the logarithm of both sides and we will get n is equal to 9. So negative 768 is the ninth term in the sequence. So we're now looking for the sum of the first 9 terms in the sequence, and that is denoted by s sub 9. So simplifying that, evaluating it, it will give us negative 1533. Okay, so it makes sense because this one is all negative. The signs of all the numbers here are all negative, so it just makes sense that the sum is negative, also a negative number. Now let's proceed to the third example. The third term of a geometric progression is 9 times the first term. The sum of the first 4 terms is k times the first term. Find the possible values of k. Okay, now let's translate the verbal statements into mathematical symbols. So the third term is 9 times the first term. Okay, so and the progression is said to be geometric. So a sub 3 is equal to 9a sub 1. But we know that a sub 3, since it is geometric, is actually a1r squared, and then it's equal to 9a sub 1. So we can cancel out a sub 1, and then will lead us to r squared equals 9. Getting the square root of both sides, r is equal to plus or minus 3. Now let's go to the second statement. The sum of the first 4 terms is k times the first term. So meaning S4 is equal to k times a sub 1. So S4 is this formula. Let's use the formula a1 r to the power of 4 minus 1 over r minus 1 equals ka1. So we can cancel out the a1. So what remains is r to the power of 4 minus 1 over r minus 1 is equal to k. Now when r is equal to 3, so our k therefore is equal to 40, and when r is equal to negative 3, our k is equal to negative 20. So the question find the possible values of k is giving us a hint that there is more than one value of k. And it is true, there are two values of k which are 40 and negative 20. Now, example 4. A geometric progression has first term a, common ratio r, and sum to n terms, which is denoted by s sub n. Now, we have to show that s sub 3n minus s sub 2n over s sub n is equal to r to the power of 2n. So, what is s sub 3n? S sub 3n, so you're going to use the sum formula of the geometric series, of the geometric progression, and all you need to do is to change the n to 3n. So in the same manner, s sub 2n, you just change the n to 2n. So let's see how it goes. So we are manipulating the left side. So this is how it's gonna look like. Now since denominators are common, then we can just divide it. Sorry, we can just subtract it like this, making it as a single fraction. And we can cancel out the r minus 1 there, right? So it will now give us a sub 3, ar 3n minus a minus ar to the power of 2n plus a, and then take note that negative a plus a is just 0. And the next thing to do is we can actually factor out r to the power of 2n. If we do that, r to the power of 2n will become r to the power of n minus 1. By the way, we also factored out the a, right? So notice that we can cancel out now r to the power of n minus 1 and also a. So uh, what remains now is just r to the power of 2n. So we have already shown that the left side is equal to r to the power of 2n. Okay, now let's go to the last example, example number 5. Joel and Jeff each open a savings account. Joel deposits $200 in the first month and then increases his deposits by $20 each month. Jeff deposits $100 in the first month and then increases his deposits by 10% each month. Now, after how many months will Jeff have more money in his account than Joel? So let's take a look at each other's account. Let's start with Joel. So the first deposit is $200. Since it is increases by $20 each month, so after this, in 2 months, now he will have $220 in his account, then followed by ace of 3, which is equal to $240. So now this three terms actually form an arithmetic sequence that has a common difference of 20. Now let's take a look at Jeff's account. So the first element is 100. That is the first deposit. Then it increases his deposits by 10% each month. So the second term is equal to 100 plus 10% of that, and that gives us 110. Now, um, you may notice that the deposits actually form a geometric sequence. So the common ratio is 110 divided by 100, giving us R is equal to 1.1. Now, let's take a look at the question. After how many months will Jeff have more money in his account than Joel? So let's put it in words. Jeff's total money must be greater than Joel's total money. Now, Jeff's total money can be obtained using the geometric series formula. And we will now have 100 times 1.1 to the power of n minus 1 divided by 1.1 minus 1. Whereas the deposits, the total deposits of Joel follows an arithmetic series. So let's use the formula n divided by 2 times 2 bracket 2 times the first term 200 plus n minus 1 times the common difference 20. Okay, now if you are taking IBDP SL or HL mathematics, you are allowed to use a GDC. So you can use GDC to find or to solve this inequality, because it would be challenging for us to do this manually without the use of the GDC or the graphic display calculator. So now, okay, so let's simplify this. Let's make it more simple. So by manipulating or removing some fractions there. So 1.1 minus 1 is 0.1. 100 divided by 0.1 is 1000. And then simplify this bracket. So that will give us 380 plus 20n. So the next thing to do now is to solve this inequality. Okay, so let's use the desmos to answer that inequality. So let me open desmos here. Okay, so I have the desmos.com/calculator. Okay, so it will lead me to this calculator. So I need to input now the left side of the inequality as one function, and then the other side also as another function. So we will have y equals 1000 bracket 1.1 to the power of x. So let's change n to x because we have x and y axis here, and then minus 1. All right, so that's the graph. Now let me input the other side of the inequality as another function. So y equals n over 2 is the same as 0.5x, then bracket 380 plus 20x. All right, so okay, so now we can see the two graphs in here, but I think we need to adjust the window so that we can clearly see the intersection of the two functions of the two graphs. So you can use the toolbar here, in which we can actually set the x-axis. So the x-axis, since based on the context of this problem, we don't actually need the negatives, so we can set the minimum to -1, and then we can probably okay, make this up to 30. While the y-axis, since this is involves money, so that means we can make the maximum y a big number. So for example, 10,000, $10,000. Okay, no need for the comma. All right, $10,000. Now you can see that the graphs have already self-adjusted, and we can do some scaling here. Let's say 500. Okay, then you now have this graph. Okay, so just adjust, drag it, and then you can see now the intersection. So the intersection point is actually the solution to the equality wherein the left side is equal to the right side. So we need to find that. Okay, so what is the intersection here? The intersection is 27.566, but what we want is greater than. Greater than, so the question in the problem is find out the number of months wherein Jeff's is greater than Joel's total amount of money. So the answer therefore here, we have to round it up, and that is going to be 28. Okay, so n is going to be equal to 28 months. All right. Display calculator, which we call TI-Nspire CX. So it's the same strategy just like what we did in Desmos, wherein we're going to graph. Okay, so I added graphs, so I can input the first function, which is denoted as f1 of x, as 1000 bracket 1.1 to the power of x minus 1. All right, now here for in the GDC, you have to put here the multiplication symbol in between. So otherwise, it will be, otherwise it won't graph. It won't give you the graph. All right, so this is how it looks like. Then I have to add the second function, which is denoted by f2 of x as 0.5x, then multiplication symbol or times 380 plus 20x. Okay, so this is how it looks like. Now the default window is this 6.67 to negative 6.67 for the y-axis and negative 10 to positive 10 for the x-axis. So which means we really have to adjust the window. So you go to menu, for you to adjust the window, you go to menu, window zoom, and then window settings. And then this is where you can adjust the minimum of x value, let's say negative 1, and then maximum for the x value, let's say 40. You can do auto scaling, let's say okay, so let's say 2 by 2's. All right, that's fine. And then y minimum is, let's say negative 2, and then the y maximum, let's set it to 10,000. All right, you can also adjust this in such a way that you will now have the scaling for the y-axis set at 500. So you will now have this graph, okay, and then you can see now that the intersection is over there. All right, it's up there, right? Okay, so now how to find the intersection point? So you go to menu, okay, and then analyze graph, okay, and then find the point of intersection, and that is 4. Okay, now you will see this broken line. Okay, so all you have to do is just enter that and then drag. Okay. Let me do it again. Okay, so for you to find the point of intersection, so let's go to menu, then analyze the graph, intersection, and then you will see this broken line, and then just drag it. Okay, so after dragging it, automatically it will give you the coordinates of the point of intersection. So here it shows that it is 27.6. So round it up, then the answer is the same as the one that we got from Desmos, which is also equal to 28. All right, so now the other way of doing this is by going to menu again and then go to table, split screen table, and then you will be directed to the table of values. Okay, let's drag it here. So the blue are corresponding to the y values for the first function, while the red are the y values for the second function. So now if you go down, so what we can do is just try to compare in such a way that f1 must be greater than the f2. So Um, okay, so let's see. The answer is actually 28, right? So if you see 28, 27, 12,110 is still less than 12,420. So it started to become greater than at x equals 28, wherein Jeff's account, which is 13,421, is greater than Joel's account, 13,160. All right, so you can also use the table to look at the values of x that satisfy the condition of the question. All right, so that's it for today. So I hope that you learned something from today's video, and I want to see you again next time. Thank you very much. See you soon.